Hello and welcome back to another episode of Dookie Forge, the show where I have no idea what I'm doing and the points don't matter. In this episode, hopefully we're going to be continuing the build on the mobile forge and making some significant progress, specifically on at least one of the folding arms. I really want to focus on that area and try to get the design and the measurements and make sure everything fits together, because that's kind of the pinnacle or the center point of the whole design. If that part doesn't work, then nothing's really going to work. So here's where we left off, just with the angle brackets attached, glued and bolted. The issue I'm going to run into is that I'm not very good at much of anything that I'm doing. Like I mentioned before, I'm not very good at math, I'm not very good at measuring, I'm not very good at building things. A lot of these things I've just never really done. So one of the issues is I have no real way to say, let's say I work on this one, which I believe is going to be my anvil side. So let's say I work on this arm. I have no system to like hold the anvil and make sure everything works, and so essentially I'm going to have to measure everything and draw it out and hope that I'm correct, and most likely I won't be. But we'll see. But that's what I have to do. I think I have a creative solution because I'm not very good at measuring, as I mentioned before. Not very good at that, and I think I have a better solution. So I just took a little bit of time and measured with the screwdriver, and I got 13.5 screwdrivers wide, 0.4 on the angle bracket. We got obviously 13, and these are just my rough drawings. Those are awesome wheels, and 12.7 screwdrivers tall. So what I'm going to do is try to take these measurements into 3D and build an accurate version of the cart, and then start building an accurate version of the fold-out arm. So I got back into 3D and started designing. If you've seen the previous episodes, you know that I actually already built all of this, but I'm kind of rebuilding it, because the first one wasn't. It was fairly accurate, but none of the parts were really built to be actually accurate. It was all just kind of close. And so what I did differently this time is I went back and walked back and forth between, well, right now I'm working on the anvil, but I went back and I would measure, and I'd go back and measure and do some changes and measure it in 3D and then measure it in real life, and then to make sure not necessarily that it's the perfect shape, but that the extents of the shape are accurate. So like the high point of the anvil, and the top and the bottom are right, and all that other stuff. And then of course I had to do everything. So the hinges, I would go back to the real ones, measure them, and the point is to make sure the pivot point and the leaf side of the hinge are accurate, and so that I can accurately make the arm the correct length based on the hinge size and how far away the anvil needs to be from the cart itself. And of course, the leg that I ended up buying, I had to make an accurate scale version of that, so the angle at which the leg actually sits, where it folds, how big the top and the bottom, the feet, and all that other stuff is. And then a lot of little things like angle brackets and all the kind of attachment points. You'll notice that the bolt counts, especially on the top section here, are different from what I was thinking in the design phase, and there it is. the final design, accurate to scale. So now we need to actually get the parts, make the parts. And first we start with the leg itself. This is a trailer jack leg, nothing fancy. It can hold plenty of weight though. Next is the base plate for on top of the leg. It's a 1/4 inch, cut out a 1/4 inch plate, and it's just to distribute the weight and help the transition between the leg and the upper arm connection point. Next, we have some of the smaller items, which would be the brackets that attach the leg to the plate to the upper arm area. And ignore the bright green area. I just did that while I was designing just to remind myself that that area needs trimmed off and shortened. So as you can probably see when I flip this thing over, one side is much shorter and squatter than squatter than the other. And one of the center point, I guess, of the arm is the actual upright. And that's made out of 2-inch outside diameter pipe, 1/8 inch wall, and of course, as you can see, a bunch of holes in it for bolts and whatnot. Some of the next parts that we have were a little bit more challenging to make as far as with the tools that I have, and that was with the actual arms themselves. To get the straight ones weren't too bad, but the bent ones, essentially, I don't really have tools to do bending and all that stuff. So I just ended up sticking it in a vise and hitting it with a hammer until I got the shape that I wanted. My neighbors absolutely love me. Next up is another challenging piece, which my neighbors love me for it, is the angle brace that connects the upper and lower arms. And I took a torch and a vise and a hammer and made a lot of noise and made that. It's a little bit different than the actual design, but it should work really well. The next part is we need hinges, which I bought some hinges that should work, and these are roughly to accurate scale of the actual hinges, and these would be it. Basic leaf hinges, nothing fancy. Eventually I will forge my own, a little heavier duty, hopefully a little heavier duty, and just hand forged. So that'll be in the future, but these will do for now. One of the next groups of pieces, I suppose, is the upper angle bracket connector pieces to connect the base plate of the anvil to the upright arm. You might notice a few things different in the actual items than the design, like that has 2 angles cut in it. Well, that's because I put it on backwards at one point and had to, instead of making a whole new bracket, I sliced both sides at an angle. And then there's these scallop cutouts on one side of the bracket, of 2 of the brackets, and that is to give room for some bolts that are below that angle bracket that I couldn't tighten, or I couldn't get a wrench in there. So I had to put the scallop cutouts in there. On top of that will be the main base plate that actually holds the anvil itself. And that is was a challenge to make just because of the tools I have. It's made out of the same 1/4 inch plate that the upper leg plate was made out of. And so it's fairly thick, fairly heavy duty, and was a real challenge to actually work with my limited tool sets. Next, I wanted to put a layer in between the base plate and the anvil. I don't know if it's necessary, but my idea was a piece of wood that I would glue to the steel and to the anvil in between those two to help with vibrations and just impact related stuff. And like I said, I don't know if it's better or worse for it, But that's what I ended up doing, and we'll see how that works out. Next up was probably one of the most challenging things to make, though one of the smallest things to make, and that is these Anvil brackets. Like I said before, my limited tool set, it makes it very hard to, well, make these kinds of things. I don't have all the tools and all the resources yet, and so this ended up being a very difficult thing to do. Lots of torch, lots of hammer, hours and hours and hours. It probably took me a good 12 hours to get these things the right shape, fit to the anvil, get the bolt holes to line up with each other and get everything. It was a real pain. And of course, last but not least, the anvil itself. It is a 70-pound NC big face anvil. So technically, not theoretically, technically it is a farrier's anvil for horseshoes and things like that. But it'll work out really, really well for what we need and should, well, last a lifetime. And there you have it, the, I guess, final design. And I'm going to, I use this final design to make all those parts and get measurements to hopefully make sure everything fits together. And I guess the next part is putting it all together and hoping for the best. Skibidi-doo bop, bididi-bop, beep-boop bop.
And now, for the grand reveal.
There it is. Finished arm for the anvil. A lot of work, but it is beautiful and solid. You'll notice a few changes from the design. One is the width. As you probably guessed, I measured wrong, but in the design, the width of the plates here were a lot narrower, and the feet of the anvil were a lot narrower. I found that out after, and I changed the design and edited it, but to make sure it's not all, it's all good. Then on these anvil brackets, I ended up going with a single bolt through both in the center. I found that since gravity is helping me, I don't really need two bolts here. And then it might be hard to see, but I added a thin layer of like exercise mat glued underneath of these things just to fill in any gaps and really squeeze in there. You can probably see it better on that one. And then I siliconed the entire bottom of the anvil. It's full, it's oozing out like right there. And it's fantastic. There's one other update that I'm going to be doing, and that is, if you look here, there is a little bit of a wobble, and I basically went through the entire design and tried to find out where the wobble was coming from, and it just turns out that it's just the flex in the steel being all vertically oriented this way. There's nothing in this design that stops it from wobbling back and forth. So one of the things I'm going to do is add basically a piece of angle iron here that when it's out at a 45-degree angle, I'm going to have a quicker removal angle iron piece that mounts to here and then mounts to the side of the cart, and I hard fasten it when it's out here, and that'll stop the wobble and transfer the wobble essentially into the cart instead of into the arm. But that's a small change, and I'll take care of that in a future episode. Let me show you how it works. Hello, and welcome to the CNN snapshot clip from our upcoming documentary, Wilson. In this documentary, we get a chance to sit down with an anonymous insider, only known as Sources. And in this documentary, we get a peek behind the scenes of what exactly goes on at Wilson and how it affects you. Enjoy. So, Sources. What is Wilson exactly?
Wilson stands for Worldwide Interdimensional Logistics and Sports Obtaining Nanoplumbuses.
And what does Wilson do?
Well, to the layman, we are nothing more than an ordinary sports equipment supplier.
That's how most people see it, yes?
But what we actually do is defend the universe from interdimensional aliens with a focus on sports-related incidents.
Sports, you say? What do these aliens have to do with our favorite pastimes?
I know it is strange, but as it turns out, these aliens have been stealing lost sports equipment for over 20,000 years, from our best guess.
And sources say that?
Yes, I do.
Well, then it must be true. Go on.
Right. Through our tireless effort and trillions in research, we have determined that these aliens survive off of the untold suffering and anguish of children that lost their baseball or football over the fence and into the neighbor's yard, only to have it never be seen from again.
I can hardly believe what you're telling me. And I'm guessing that not only is Wilson the front to all this activity, but it's a way to resell the reappropriated sports equipment back to the public?
Yes, that's exactly right. Our goals are to protect the universe and bring back a little joy to a child.
Whoa, wait a minute. I don't mean to interrupt you, but if I'm reading into this correctly, so what you're saying is that sources say that Wilson steals from illegal aliens just to pawn those goods back to the American public? Is that right?
Well, no, that's not exactly the best way to...
Sources say Wilson hates illegal aliens. What an amazing clip from an amazing upcoming new documentary, Wilson, coming to the world's most premier streaming service, CNN+. So, first things to use the arm, typically it would be folded up. Oh, there's all the parts for the vice arm. So typically it would be folded up, and I would unfold it and put the leg down. But essentially, I'll do the reverse. So it's you take the weight off the leg by just pressing down on this lever. I just used my foot because it was easier. And then you pull up the leg so that's not touching the ground. You pull down, and then you fold it up. And there we go. The entire arm is folded up, nice and clean, and it's really easy to hinge. Now, one of the mistakes, I guess, is that originally I wanted it to this part of the anvil to dip right underneath the layer of the cart. Me and measurements just didn't quite work out, but it's still all good. It still folds up straight, and I didn't have to go back to the drawing board and change anything. But it folds up really nice. It unfolds even nicer. And yeah, that's how it works. One other change that I did have to do involves this leg. Let me pull it down. As you might notice, the front of this foot is chopped off from maybe when we saw it earlier. And that's because my measurements, as usual, didn't take into account the legs sticking out like, you know, 1.5 inches further than this. And when I would go to fold it up, it would just always hit the ground, and I couldn't fold it up. And so I had to chop off the front of each of these feet to make it all kind of fit and work together. I think, one other last change that I ended up doing was in the design, this was kind of a harsh angle. It went from this bolt to this bolt, and I changed it to be to make it easier for me to bend. And I ended up just going between these two bolts and these two bolts, this was like the design. The reason I didn't go between a single bolt like I originally thought I was going to, I just didn't want essentially between a 2-point angle brace, it can still spin a little bit. And if there's 2 anchor points on each side, there's basically no chance of it spinning or twisting at the shear weight on the arm. So that, I don't know, I'm very happy with how it came out, given all the mistakes that are in it and everything, but how easily it folds up, how easily it moves. I mean, look at that. You cannot ask. And now I get to do it all over again with that. All the parts for the vice arm. So let's get to it. So as you can imagine, the parts breakdown, I suppose, for the vice arm is very similar to the anvil arm. A few changes. Start off with the leg, and then a 1/4 inch upper plate, a couple brackets to attach to the main center point arm upright post thing. And so these are very similar. The next part is a little bit different. It's much taller. The holes are a little bit more spaced out as far as where the brackets attach and things like that, because it's a lot taller piece. Next up, these arms are actually the same between the vice and anvil arm. The holes are a little different because I actually did better this time measuring. And you might notice some heat coloration on that one. And that was on that one arm because that was while I was making this angle bracket. I kind of bolted it in place and heated it while it was on the arm, and to bend things into shape to fit things together. Next, of course, is the leaf hinges. And like I said, I will hopefully forge some new ones in the future. Then we have the upper brackets that will attach the base plate of the vice to the main arm. And of course, the base plate of the vice. This one I cut to shape so that anything that I put in the vice has no extra interference from the base plate extending past the base of the anvil or anything, or base of the vice. And of course, I'm not doing a piece of wood under this because I typically won't be hammering on this exclusively. And this is the vice I plan on using. It's fairly large. It's the largest vice that I've ever been around. And that's what she said. So now let's put this thing together, shall we? Skibbity-bop-beep. Beep-boop-bop-beep.
And now, for the second epic reveal.
There it is, the vise arm. Look how easy that moves. Just like the anvil, it's very smooth. Now, just like the anvil, it also has a little bit of a wobble. I'll lower the leg here in just a second and show you. But it is done, done. It folds up all beautifully. It unfolds beautifully. Obviously the stand is a lot taller, mainly because I like the vise to be a little bit taller. It's just more comfortable. This, of course, folds up nice and clean. And then you drop it down. You use this thing. It's just a trailer jack. And there we go. So, gotta lift it up a little bit more before I can get it in the other hole. That's what she said. Normally I would step on it and it'd be a little easier. Ooh, it's a little too high, but you can see it takes all the weight off the cart into the wheel. I wouldn't normally lift it quite that high. I'd leave just a little bit of weight on the wheel. But there it is. It's up. And the wobble is pretty much the same, except it's a little bit more accentuated because the whole system, the vise arm itself is just a little bit taller. I may or may not add an anti-wobble attachment from here to the cart at 45 degrees as well. But the wobble on the vise isn't as important. I just have to be careful. I probably can't like put all my weight on it in like side to side direction. I'd have to, rotate the vise and then pull in a linear direction in the direction of the arms to make sure I don't bend anything. So I may add a wobble bracket when 45 deployed as well, just to help stabilize this, but that will be later on. I am very pleased, very happy with this. It was a lot of work, but they're both deployed, both up, both functional, and both solid. Oh yeah. So here's the cart as I kind of left it, and I'm gonna fold up the legs, roll it around a little bit just to kind of feel it out, test it out. So yeah, let's do it. Let the weight off of the leg. And then I'm gonna fold it up. Same thing for the anvil. Up. Everything is, I am a little worried about when I let the weight off the leg, it does, drop a little bit. So that's why I don't want to necessarily lift the cart too high, because I don't want the weight to drop. But considering it's handling the weight so well, the little bit of dropping I don't think will overly wear out the hinges. This is actually the first time I've folded up both. Now I know it won't fold up, they both won't fold up flush, but this is pulled against the anvil and everything is pretty tightly packed. Obviously, it could always be better, but I am very happy with this. Now let's turn off these brakes and just move it around a little bit just to feel it. I'm not going to do too much because I'm going to have a chain system to hold the arms while I'm rolling it around, hold the arms in place. But just rolling it right now, it almost takes the same amount of force as if the cart was empty. It doesn't really feel any heavier. Obviously, the arms are moving around a little bit, and they will be fastened. And I plan on taking a chain from the top of this bracket underneath this arm, and then underneath that arm, and then back up, or however I end up doing it, back up to the top of this bracket, and then tightening it up so that it should hopefully take a little bit of weight off the arms while I'm rolling it around, so it's not constantly bouncing on the hinges. And then also obviously keep them tight, because the last thing I need is me rolling down the sidewalk and this thing swings out and, you know, chops an old lady in half. But rolling around, I mean, that doesn't take any more, like, I'm just gonna push it just lightly. It doesn't take any more pressure than almost when the cart was empty, which is really nice. And then it's this easy to deploy. You just roll it out. Boom, bam. Fold out the leg. Up. Then you take your lifter, lift that side, lift this side. Don't know how much yet each side should be lifted, but it's not very much, believe it or not. And I don't want to necessarily take too much weight off the wheels, so there we go, a little bit. So essentially to the second hole and just a little bit up, and that's pretty much it. There we go. Now, like I said, it's more important for the anvil, but I will be adding a bracket on this side that I will take on and off every time I deploy this arm, and that will rigidly mount to keep the little bit of wobble here. And at some point I probably will redesign maybe this upper arm and reforge a more sturdy hinge, so that way the arm itself won't wobble. Maybe use actual angle iron instead of just straight bar. But I will, at least temporarily sake, put an anti-wobble attachment in there. Look at that. Bada boom. Come over here. Tighten that. Got yourself a really nice vise, really nice anvil. And the idea is to have the forge right here on this side of the cart, and it'll about be this much, you know, about take up the middle section here. So doors will open like this. Have both sides, both sides have doors. I'll have access to the forge. I can take it out, walk over here, boom, boom, boom. Or I can be on the other side, have easy access to the cart, or to the vise, or I could be working in the middle, which I plan on putting a piece of wood, like a butcher block, little workbench thing here for a softer surface when I need it. I can work here in the middle, have quick access to both. I think this is going to work well. There are some improvements that are needed, and those will happen over time that I've discussed some of them, and I've found some of them that will need to be addressed for the future, but it's pretty cool. It's pretty cool. For never doing anything like this before, never really having tools or anything like this. I am very, very excited and very happy for the near future. We're going to be outside soon, giving this stuff its first official test. And that will be exciting. So stay tuned for the next episode where I will be fixing up the, am I even in the frame? I don't even know. I will be working on, it's right over there on the shelf, it came in, and I'll show it closer in the next episode. But I will be working on the forge itself and getting it, the cement on it and setting it up and test firing it out back in the back alley. And I'll take you along for that ride. So have fun with this week's quote of the week.
Hey, who's that Quotamon? Hey, look at me. I'm Jeremy Renner from that Marvel hit show, Arrow. I'm so cool. I'm like hanging out of this car, and I'm like, hey, you wanna know what this car sounds like? It sounds like this. Isn't that so cool? I'm so manly. Look at me, look at me, look at me. Anyway, I have a really good quote for you this week, and it's just from the most amazing movie or series of movies that has ever existed. You know, like, okay, anyway, here it is. Family. 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 Okay, bet you can't get it. Bye.